My final product is a working gas alarm that, when in the presence of higher than normal levels of combustible gas, alerts the user to the issue. By doing this, lives can be saved in the case that the leak cannot be stopped and an explosion is imminent, or when faced with the danger of poisoning from the inhalation of these gases rather than fresh air. My original prototype was simply a blueprint schematic with estimated dimensions. This was transformed to a more realistic version in Prototype 2, which still took up more space than needed, and was thus shrunk down to the final prototype, with a length of just under 6 inches, width of just under 4 inches, and a profile of not even 3 inches, the only protrusion being the MQ4 gas sensor and the 4 screws for a removable top. I made this product to help address lab incidents in schools and research labs, from gas leaks that can incapacitate to more serious issues like lab explosions. This was an issue for me as I want to work in an experimental lab after I received my degree, and I've seen incidents like these happen before. This video is an example of how the product would work, and is using a 40% ethanol solution to alter the resistance of the air passing through the sensor. The way the product works is through the MQ4 gas sensor and the reacting piezo speaker and the LED lights. The MQ4 runs an electric current through a 6-point crossing, and based on the pre-calculated resistance feedback it receives, gives off an analog value. The higher the value, the higher the resistivity of the circuit, and hence a higher ppm value of combustible gas. The sensor is more sensitive to gases like methane and butane and hexane, but still reacts to ethanol and pure H2 gas, as well as liquid propane gas, LPG. When the resistance of the circuit changes above certain points, determined by the chart pictured, 3 LEDs signal the level of severity based on color, and the RGB LED helps to get the attention of the users. The piezo speaker, although weak, is a source of an auditory alert. Thanks to the skills I've developed through the engineering series and skills I learned predisposed to that of the electrical, chemical, and mechanical engineering disciplines, plus small bits of knowledge from many other engineering disciplines, I was able to make this product work properly. Thank you to all of my professors that guided me through the 120 series.